Okay, lesson for today. Solving quadratic equations by graphing / factoring. I don't know, that's fine. The better thing to think about today is we're going to go from factors to solutions. And another name for solution is roots. And another name for solutions is zeros. And another name is x-intercepts. Like all those are kind of the same thing. So we're going to go from factors to solutions. / roots, / zeros, / x-intercepts. And then toward the end, we'll kind of go backwards. We'll start with our answers and come up with the questions. That's sort of like the Jeopardy route, right? Like, here's the answer. What was the question? But you can't really do Jeopardy unless you know all the facts moving forward. So we'll go forward first, make sure we understand factoring, setting them equal to 0 to get our answers, and then we'll work on going backwards. So very first one, what are the factors of that expression? Hey, that's what the quiz is on, is factoring. So we're reviewing for the quiz even now. What would you like to do first on this question to start to factor it? So let's take out a -1 or a negative sign. So x squared plus 2x minus 3. Makes our factoring life a lot easier. That negative's still there. And so I need to sort of unfoil this. It's got to be x and x to get to x squared. It's got to be 3 and 1 to get to 3. And then it's just a matter of signs and combining to get 2x in the middle. Let's see, I need my signs to be different. And I need it to add to 2, so I want a plus 3 and a minus 1. That would give me 3x minus 1x. That's the 2x. So there's my factored expression. And the negative sign can't go anywhere because it's not an equation. I can't divide by it and make it go away. It just has to kind of go along for the ride. You can mark out graphing and table. Let's worry about solving this thing. So if this was equal to 0, this is what you're used to. You've done this before. You can set both of the factors equal to 0. Does that sound familiar? It's what some of you wanted to do the very first day we were factoring, and we had to say, no, slow down. We're not there yet. Well, now we are. If it's an equation, if it's equal to 0, then you can set the factors equal to 0. And then solve for x. And many of you will skip this step, right? You kind of do that in your head, or you know that you just change the signs, and so you just tell me x is 1 and x is -3. And that's okay, although we're going to get to some harder ones where it might be wise to write out this step. Jenna?
What happens to like the negative?
That's a great question. So if we're multiplying things to be 0, that means one of the things has to be 0. And so I guess we could put all 3 factors equal to 0. But you can't have -1 equals 0. So we throw that one away. But I'm glad you're looking at that, because there's times when we factor and there's an x out there. So that would be x equals 0 if there was an x there. But if it's just a number or a sign, it doesn't really contribute to our solutions. Okay, so that's kind of the main thing for today is, hey, we know how to factor, hopefully. Now we're going to take our factors and set them equal to 0. So, like, the hardest part of today's lesson is the stuff that we should already know, right? Like setting it equal to 0, this is the easy part. It's this factoring part that we've got to make sure we're okay with. All right, the next couple lines are kind of just emphasizing stuff that we've kind of already talked about, and that is these are the x-intercepts. So 1, 0, and -3, 0. So it's like it's not a separate deal. Like those are the x-intercepts. And they are the solutions to that equation. So zooming out, like figuratively and literally on the page here, it's trying to emphasize that zeros, x-intercepts, solutions, those are kind of all the same thing. I mean, they represent slightly different things, but they're all the same set of numbers. The zeros of the equation come from the solutions to when you set the equation equal to 0, which gives you the x-intercepts. And again, so those are all sort of the same thing. Okay, zooming back in. At the bottom, this is kind of an easy question if you understand what's being asked, but I want to make sure we go over it because there's one like it on the test. Use the table to determine the location of the zeros of the quadratic function. Whoop, there should be an of in there. So let's just plot all those points and see what we learn. So -2, 9, -1, 1, 0, -5, 1, -9, 2, -11 is just off the graph, almost off the page. 3, -11 down there as well. 4, -9. 5, -5. 6, 1. 7, 9. 8, 19. I'm not graphing that one. That would be way up there somewhere. Give me a second to finish plotting those points. And then we can connect the dots carefully. Okay, so there's my parabola. And I'm looking for the zeros, also known as the x-intercepts. Also means that's where does y equal 0. But I don't know them exactly, right? Like, I mean, I can see them on the graph. It's right there and right there. But I don't know what those values are. And so this question is a little misleading because what we really want is for you to tell me where are they between. Like, get me as close as you can. So that first one, what x values is it between? The 0 is between what and what?
0, negative.
Yeah, between x equals -1 and x equals 0. And that's kind of as good as we can get on this picture. I mean, I guess you could say it's closer to -1, but I believe that by the picture, but that you couldn't really get any more accurate than that. And the other one is between, on this other side, 1, 2, 3, 4, 5, and 6, between x equals 5 and x equals 6. Is there a way we could have done that without doing the picture? Like looking only at the table? What are you looking at, Jenna, to get those values off the table?
Just like wherever it's like 0 like in between points.
Yeah, wherever y is 0 in between the y points. Like to get from 1 to -5, we got to go through 0 somewhere. So there's got to be a 0 between -1 and 0. And then same thing on the other end over here. When we go from -5 to 1, got to be a 0 in there somewhere. Probably closer to 6, but can't say for sure. We'll just say it's between 5 and 6. So on that question, if you want to graph it, sure, fine, but it would be quicker and easier if you sort of understood what Jenna was explaining. There's a 0 in between there, so my x values have to be, or the x value happens between -1 and 0. There's a 0 in between there, so it's got to happen between 5 and 6. So it's an easy question, and just making sure you understand what's being asked. All right, we're going to throw out this word problem. Let's talk about the zero product property. I feel like this lesson's a little out of order because we've already used this. If A times B equals 0, then either A is 0 or B is 0. Right? If you're multiplying two things and the answer is 0, the only way that can happen is if one of the factors is 0. There's another fancy math term for the two things that are being multiplied. I guess factors is it. Does that make sense? Like the only way, if you got two numbers multiplied to be 0, one of them's got to be 0. We don't talk about that a lot, but you use it all the time when you solve by factors. Because you factor, and then you set each factor to 0. So you're using the zero product property even though you're not really thinking about it. And so we want to mention it, but it's not like I'm going to say, prove that that's right, or use that, or tell me how you know. Like, it's just something we use. Okay, solve by factoring. Again, this is what some of you wanted to do the first day we were factoring. How do I know, even before it says solve by factoring, how could I know that I could solve this rather than just factor it? What's different between a just factoring problem and a solve by factoring problem? Yeah, the equal to sign. So that means I'm going to get x equals something and x equals something. I'm going to solve it. So factoring is how we get there, but we're not going to just stop with the factors. Let's see, x and x. Factors of 21. This one's pretty easy, right? It's not 1 and 21. 3 and 7. I can make 4 out of 3 and 7. I need their signs to be different to get to negative 21. But I need them to add to a positive 4. So let's go plus 7 and minus 3. 7x minus 3x gets me the 4x. On the quiz today, that's where we would stop, because there's not equations. You would just factor. But now we're taking it that one extra step, and we'll set the factors equal to 0. This is the step that many of you skip, and many of you should skip, right? Like you kind of know what's happening, and you just change the signs and say x equals 3 and x equals negative 7. B looks a little different for a couple of reasons. What do you want to do first on B? Let's set it equal to 0. So I'm going to move the 8 over. Negative 3x squared plus 2x plus 8 equals 0. Still kind of yuck. What do you want to do on this one? Okay. Factor out a negative 1 is a good answer. There's something else you could do. Because it's equal to 0, it's related to the negative 1 thing. But rather than factor out a negative 1, I could, I was going to multiply, but divide would be the same thing. Multiply or divide by a negative 1. So it accomplishes the same thing. It changes the sign. That's what we want. But it also throws away the negative 1. We don't have to worry about it anymore. Now, if you factor it out, it's fine, because it's not going to lead to a solution. Alright, this is one that's a little bit harder. 3x, my only options are 3x and x. To get to 8, I've got choices. And because of the plus minus stuff, I've got lots of choices. Alright, I need to make my double smiley face add to negative 2. I think I said yesterday that we usually like to start at the inner factors, not the extreme factors. So I'm going to put 2 and 4 down there and see what happens. But almost as soon as I write that, I'm like, wait a minute, that's 12x and 2x. So even before I start thinking about the signs, I'm not getting 12x. I'm not getting 2 out of 12 and 2. So 4 and 2 can't go there. If I switched them though, maybe, go 2 and 4. Now I've got 6x and 4x. Okay, now I can make negative 2 out of that if the 6x is negative and the 4x is positive. And so I've got negative 8 at the end, that's right, 3x squared at the beginning, and I've got the negative 2x. Okay, factors, set each factor equal to 0. This would be one where it might be wise to set that equal to 0. But the other one's easy. X minus 2 is 0, so x equals 2. Do the easy one first. 3x plus 4 equals 0. I mean, it's not hard, but you can't just move the 4 over. You've got to move the 4 over and divide by 3. So, again, many of you are going to skip showing that x minus 2 equals 0. A few of you might skip this step as well, but I don't know. I think that it's probably helpful to show to make sure you land at the right spot. Right, part C. I'm going to move over the 28x and the 12 so that it equals the 0. And it doesn't matter which side you move it to, but I want the x squared to be positive, so I moved the things over that would keep the x squared positive. Let's see, let's factor out a 4. Which means I could have just divided by 4. Although this time I'm going to leave the 4 there to show you what it does and what it doesn't do later on. Okay. I got options for 6. I don't have options for 3. That's got to be 1 and 3. So I'm going to go ahead and put the 1 and the 3 in there, in pin. And then on the other side, it's either 1 and 6 or 2 and 3. But I'm going to start with the inner factors first. So let's go 2x and 3x. That would make 6x and 3x. And I can't get 7 out of that. Right, I'm trying to combine those. This is the outside and inside of FOIL. I'm trying to combine those to get 7, but that's not it. So let's switch the 3 and the 2. Maybe that'll work for us. 3 there and 2 there. Now I've got 9x and 2x. Okay, now I'm close. I got to have different signs to make negative 3, which is good. I need different signs to get to negative 7. So I need a negative 9x and a positive 2x. All right, let's set our factors equal to 0. I can set all 3 factors equal to 0, but 4 equals 0, that doesn't make sense, so I can throw that one out, which is why we might have divided by 4 in the first place and just gotten rid of it. So x equals negative 1/3. Anybody want to skip the step on this one? Can you do both? Both. There's probably 3 steps. Set it equal to 0, move the 3 over, and divide by 2, and you get 3 halves. So you could still skip the step and jump to the end. It's just a little bit harder when there's a multiplier on there. All right, all that stuff you've done before, you're pretty good with that. What's new is this last question is kind of a Jeopardy question. With my Alg2 voice on and play some music in the background. Because we're giving you the answers, and we want the question, like what equation did this come from, if those are answers. So I'm actually going to start at the bottom. It's going to look weird maybe. So my answers are x equals 4 and x equals negative 2/3. And I'm going to work up the page. And then when I'm finished, it'll look like a normal problem, even though I worked it backwards. So x equals 4. That means before we got there, it was equal to 0. So what would I do to make this equation equal to 0? It's a little bit weird because we're not usually doing that, but I can subtract 4 over and get x minus 4. Which means, what was the factor that led to this equation? All right, we said our factor is equal to 0, so that means our factor was x minus 4. All right, the next one's a little bit harder because of the fraction in there. What do you want to do first on the second one?
Multiply by 3.
I like multiplying by 3. You could move the 2/3 over and then multiply by 3, but I think multiplying by 3 first is the way to go, because then you don't have fractions anymore. Then we can move the 2 over, and so there's our other fraction, or other factor, excuse me. So if we multiply those two together and set it equal to 0, there's our factored form, except we want standard form. So how do I get from factored form into standard form? I'll need to multiply those. So that would be 3x squared plus 2x minus 12x minus 8. Then combine like terms. I don't want to box that up because it asks for an equation, so it needs to say equal 0. So working backwards. Kind of weird. Alright, assignment is this worksheet. Let's do a couple together real quick and then we'll do the quiz. 1 through 6 are super easy, but they're almost so easy that people miss them. So let's do number 1 together. Use the related graph to determine its solutions. So I want the solutions to this equation for number 1, but they give me the graph. So look at the picture, and what value of x makes the graph equal to 0? Negative 3 and 1. And you're like, what, that's it? Yep, that's it. It's just trying to get you to make that connection that these zeros are the solutions. So 1 through 6 is super easy. Just don't get confused by how easy it is. And then let's do one more. Let's look at number 9. This is another Jeopardy question. So x equals negative 1/3. X equals negative 3. Some of you are going to start skipping steps on this one because you're going to be able to jump ahead and figure out what the factor is. I'm going to slow it down here. 3x is negative 1. That means 3x plus 1 is my factor. And x plus 3 is the other factor. And then I just multiply them out. 3x squared. To save time and space, I'm going to multiply and combine in the same steps here. So plus 10x plus 3. And it does want an equation, so I'll write equals 0 on the end of that. Alright, so 18 questions, but 6 are super easy, and the rest you've done before, really.